So today I want to talk about the electrons in the Bohr model in more detail. For example, this is Copernicium, or Copernicium. It's 112. It's got 112 electrons. It has seven orbits. Sorry, 7 orbits, and the electrons fit in there in specific numbers. And you can see, like at the top here, that I have the numbers of electrons in each orbit kind of laid out. Just so it's easy to kind of tell what's in this picture here. But how do you generate a picture like this with this many electrons? Well, first off, the one thing you need to understand about orbits here is that there's actually something called like a suborbit. Okay, a suborbit or suborbitals. So essentially, each orbit is consisted of several mini orbits that are kind of close together that we kind of consider to be one big orbit, but they're actually slightly different. And electrons can actually jump around between these little suborbits as well and give off low-level radiation like infrared or radio waves as they jump in between these very tiny orbits within the same orbit. So it's like a suborbit here. Now, there are 4 types of suborbits. Okay, they actually have names: S, P, D, and F. We gave them letter names. Okay, each suborbit can hold a different number of electrons. So an S suborbit can hold 2 electrons. A P suborbit can hold 6 electrons. A D suborbit can hold 10 electrons. And an F suborbit can hold 14 electrons. Now, the first orbit, very first ring around the atom here, this orbit here has only one suborbit. It's basically the orbit is the suborbit, and that is an S orbit. Okay, so this can only have a maximum of 2 electrons total. But the second one, this is where we get 2 suborbits. You will see that you get another suborbit every time you go out one. So the second one has 2 suborbits, an S and a P. So the S can have 2 electrons, and then the P can have 6 electrons. And actually, it's going to fill in the S first before it starts filling in the P, because the S is actually less energy. So it will actually fill in this inner S suborbit before it starts filling in the P. Okay, when we get to the third, now we have the S and the P suborbits, but then we also have a D suborbit, which can fit 10 electrons. Okay, when we get to the fourth, we have the S, P, and D, which fits 10, 2, 6, and 10, respectively. And then we get the F suborbit added in the fourth orbit. Okay, so this one has 4. If we were to go to the 5th orbit, that would also have 4, because none of the elements have enough electrons to actually completely fill in the 5th orbit. So although there is a 5th orbit with 4 suborbits, there isn't an element that actually can fill into a 5th type of suborbit, although it might exist. There's theoretical here. Okay, now in the Bohr model, all of these orbits are drawn as circles. Okay, that's for simplicity's sake. However, quantum mechanics has shown us that these orbits are not circular. They're not even like in 3-dimensional. They're actually more like 3-dimensional shapes. The S suborbit, okay, is a sphere. So it is kind of circular here, but it's spherical. So you can imagine the electrons kind of going around their wave pattern as a sphere. The P suborbit, it can actually form sort of like this dumbbell shape. Okay, and you can have one going up and down, you can have one going side to side, and you can have one going in and out. This is actually why you can have 2 in the S suborbit and 6 in the P suborbit. It's because you can have up to 2 electrons in every suborbit, essentially. The S suborbit, you have 2 electrons going around in this spherical shape, but then in the P suborbit, you can have up to 6 electrons, because you would have 2 electrons going back and forth, 2 electrons going up and down, and 2 electrons going right to left. So you actually have kind of 3 mini versions of the suborbit that are all equal to each other. They're just going in different directions. Okay? The D suborbits and the F suborbits, same idea. Once again, they're in pairs, so the D, you can have up to 10 electrons doing this, 2 doing every single weird shape here. The F suborbit, you can have 14 electrons, 2 doing each of these 7 different kind of shapes here. And these ones get kind of weird. You get kind of 4-leaf clovers and donuts in here. These shapes are actually based on empirical data, calculating what these electrons are kind of doing. So we do know what these look like, but it's kind of crazy here. So anyways, that's what they really look like. Let's stick with circles, shall we? So if we pretend that these are circles, like in the Bohr model, they're not, but if we pretend that these are circles, electrons, as they fill into the atom, they will attempt to fill in close to the nucleus first. Okay, so if you have an atom with 1 or 2 electrons, those 1 or 2 electrons will always go into the first orbit, and they will be in the first suborbit first. Okay, so you will get 2 electrons in that first suborbit. The second orbit has 2 suborbits. So you've got 1 for the S and then 6 for the P. Okay, so 2 electrons in the S and 2 in the P. It will fill in the 2 in the S first. Okay, so you will get 2 doing that S orbit. And then the P orbit is just a little bit higher energy. So it will then fill in that same second orbit, it's a suborbit here, the rest of the 6. Okay, so you'll get a pair of electron each, doing each of those 3 up, down, left, right, back, and forth. Okay, so you'll get 6 of them now in the second orbit. That adds together 2 plus 6 to make 8 total in the second orbit. Right? 2 of the suborbits add together to make the 8 total. Then we go and fill in the third suborbit, the third orbit, with 3 suborbits in it. So we always fill in the S's first. Okay, so first we're going to get 2 electrons as that S shape, okay, the S suborbit. Then we're going to do the P's. So we're going to get 6 electrons doing that P shape. Now this is where it gets a little weird. Okay, the D suborbit with 10 electrons is actually higher energy. It's actually harder for the electrons to get into that D suborbit than it is for it to be in the 4th orbit that's an S. So what actually happens is instead of finishing the 3rd orbit and finishing that D suborbit there, it will then go and put 2 electrons in the 4th orbit, the S suborbit in the 4th. Okay, so you'll actually get 2 electrons that basically skip finishing out the 3rd and go into that 4th. Once you have 2 electrons doing the S in the 4th, then more electrons will start filling in the D's in that 3rd. So you'll get 10 electrons filling in that D's. Only after the 4th has 2 electrons, though, has that S suborbit in it. Okay. Once you get all of the D's filled in, then it goes back to the 4th, and it finishes out the 4th P's. So you get 6 there. Okay, so you get 6 electrons doing that P's. So far the 3rd is completely full. It only has 3 suborbits. So 2, 6, and 10, add those together, you get 18 total in the 3rd. Okay, 18 total in the 3rd. It's going to fill in 2, then it's going to fill in 6, and then it's going to fill in 10 after you have 2 in the 4th. I know this is confusing. Okay, so let me back that up again. You put 2 in the 3rd, then 6 in the 3rd, then 2 in the 4th, then 10 more in the 3rd, before going back and doing 6 more in the 4th. Okay? Now that we currently have 8 in the 4th actually has 4 suborbits, right? You have the 10 D's again, that D suborbit. That one is not going to fill in until the 5th has at least an S in there. So I can't put them in yet without having a 5th orbit here. So try to expand this a little. So now I have a 5th orbit, which in theory would have 5 suborbits, but none of real-world examples we've actually been able to find with 5 suborbits, just because there's none with that number of electrons. So this fills in same basic pattern. I already have the S's and the P's for the 4th one, the 2 and the 6. Okay, so before I can put the D's in, I have to have some S's in the 5th, so I need those 2 electrons to go into the 5th. Then it goes back and puts those 10 electrons into the fourth orbit, okay? That suborbit in the fourth orbit. Okay, so we get those 10 there. We're up to 18 now, but remember there's 4 suborbits, and we haven't finished filling out that fourth yet because there's still a whole nother suborbit added in on that fourth there. Okay, that next suborbit, though, is not going to fill in until I have something in the sixth. Okay, 2 levels above it. So similar to the Ds, all right? So after we do the Ds, the 10 electrons in that fourth, we get 6 electrons now in the fifth, okay, doing those Ps. Then we're going to need a 6th orbit. Now, this does have some suborbits there, but I'm just trying to simplify it. So we're going to get 2 electrons in the 6th before going back down to the 4th and finishing out those 14 electrons. Those are the Fs. Okay? Once those 14 electrons that are Fs are filled out, then we go and fill out the Ds in the 5th. Okay? Ds in the 5th, and so 10 electrons there. And then we go back to the 6th, and we fill in those 6 Ps there. Okay, so there is a pattern here. If I kind of back it up here. So as we do this, okay, currently I just filled in the 6 electrons in the 4th. Next will come 2 electrons in the 5th, then back down to the 4th for 10 electrons, then back up to the 5th for 6 more, then 2 in the 6th, then back down to the 4th for 14 more, then up to the 5th for those 10, and then up to the 6th for those 6. So essentially, guys, it's always going in order of 14, then the one above it, 10, then the row above it, 6, then the row above it, 2, and then we kind of repeat the pattern, 14, 10, 6, 2, 14, 10, 6, 2, except if we don't have 14, we go straight to 10. And if we don't have 10, we go straight to 6. So kind of here is what happens in the different levels. Okay, so in the first level, we have 2 electrons. Second, we're going to get 2 and then 6. Third, we're going to get 2, 6, and 10. Fourth, we're going to get 2, 6, 10, and 14. Fifth, we're going to get 2, 6, 10, 14, and possibly more, but we don't have anything big enough. 6, we're going to get 2, 6, 10, 14, and possibly more, but we don't have anything big enough to go past the 10 there. The 7th, we're going to get 2 and 6, and possibly more after that if we have bigger elements. Okay, so the way this fills in, okay, you are essentially going to go in order of biggest number of electrons to smallest as you go. Okay, so when we have the first orbit, we're going to have just those 2 electrons. Okay, then we get to the second orbit, and we're going to do those 2 electrons. Okay, but then when we get to the third orbit, this pattern starts to take over. So we're going to get 6 electrons in the second before moving up to the third and doing 2. Then we're going to do 6 electrons in the third, because there are no Ds in the second, okay, before moving up and doing 2 electrons in the fourth. Then we're going to do 10 electrons in the third, 6 electrons in the fourth, 2 electrons in the fifth. Okay? Then we're going to go back down and do 10 electrons in the fourth, 6 electrons in the fifth, 2 electrons in the sixth. Then we're going to go back down to the fourth and do 14 electrons in there. Fifth, we're going to do 10 electrons. Sixth, we're going to do 6 electrons. 7, we're going to do 2 electrons. Then we're going to go back down to the fourth, 14 electrons, 10 electrons in the sixth, and then 7th, we're going to do 6 electrons, and that is actually the largest element we have. So in theory, we should have another row where we do 2 electrons, but there isn't anything there. So it fills in as, if you follow the arrows here, kind of like this downward pattern, it goes this, then 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 this, this, then this, then this, this, then this, then this, then this, this, then this, then this, and in theory we would then fill in this, but nothing is big enough for that. After that, we would then go back and probably start filling in a 5th or suborbit for the 5th orbit, but nothing is big enough. And that's how they fill in. Now, next, I'd like to define 2 basic terms for you. They are valence electrons and kernel electrons. Okay, so we have all these different orbits. Valence electrons is a term that refers to just the outermost electrons, okay, whatever is in the outermost orbit there. So if you only have one orbit, it's all of the electrons. If you have 3 orbits, then it's just the thing that is in the third orbit, the outermost one. Okay? If you had 4 orbits, it's just the electrons in the fourth orbit. So the electrons that are in your outermost orbit, those are your valence electrons. Now, why are those important? It's because those are the electrons which are going to do chemical reactions. So we're going to talk a lot about valence electrons. Okay? The valence electron is the one in the outermost. Now, kernel electrons, that term refers to literally all the others. Okay? So helium here doesn't have any kernel electrons because it only has one orbit. So all of them are valence electrons. But chlorine, which has 3 orbits, the valence electrons are the ones in the outer one, the third one. The kernel electrons would be the ones in the first and the second. Okay, all of those inner orbits. Okay, those would be the kernel electrons. They're never going to do any chemical reactions. The only thing they're ever going to do is kind of jump around when they absorb or emit light, if there's a jump there. But anything in that inner orbits, not going to really do any chemical reactions, so we give them a special name, kernel. Valence electrons are the ones that do stuff with chemical reactions, so they have a special name. Okay, so chlorine here would actually have 7 valence electrons because it's got 7 electrons in the outermost orbit, third. Okay, helium would have 2 valence electrons, all of them because it only has one orbit. Potassium would only have 1 valence electron. Only one is in that fourth orbit. All the rest would be on the inner orbits, and they would be kernel electrons. Okay, so potassium with 19 electrons would have 18 kernel electrons. So, question for you. Carbon. Carbon, which has 6 electrons total. How many of these electrons are valence electrons? If you said 4 electrons, you were right. There's only 4 in the second orbit, because this has 2 orbits, so the first 2 are kernel in that first orbit, and then the second orbit we have 4 there, so 4 valence electrons.